Okay, hi everyone, welcome to the second dialogues of the semester. The topic on this one is the machine. And to start off, we're just going to say what the roles that we have during the event, and I will be the Googler. So if you have any images or any suggestions, I will be Googling it up and putting it up on the screen. And my name is Valeria Sierra and I'm a graduate student.
My name is Kate Hammers. I'm a graduate student. I'll be the historian, so I did the poster design, and then I'll be taking pictures today.
My name is Katie, and I'm an undergraduate student. I'm going to be the crowd surfer. We have a little bit different setup today. We're not going to be handing around microphones. We have this cool microphone gun that I'll be pointing at you guys when you're talking, so don't be freaked out. But yeah, so if you have something to say, we'll be over shortly so we can all hear your lovely comments.
And I'm Ana Laura Almeida. I'm a graduate student, and today I will be moderating this dialogue for today. So I guess we'll go ahead and get started. I'm going to go ahead and start by introducing our panelists. First we have Dr. Bewlings. She received a PhD in architecture at the University of California in Los Angeles. She received her master's in architecture, in civil engineering techniques from Free University of Brussels in Belgium. She also received her master's in a master's in architecture from the Higher Institute of Architects, St. Luke's, Brussels in Belgium. She is also the founder or the co-founder of the Education of Computer-Aided Architectural Design in Europe. Next we have Professor Niemann. He holds a Master of Architecture from Yale and a Bachelor of Architecture from the University of Cincinnati. Professor Niemann has received several honors for a series of self-generated architectural design projects, competitions, and teaching involving improvision, order, and variation on the theme. His studios and design workshops exploit the strengths of both traditional and digital media. His students have won the Form Z Joint Studies Award of Distinction Program several times. He earned the American Institute of Architects Education Honors Award in 1994 and in 1998. He also received the Association of Collegiate Schools of Architecture Faculty Design Award in 1990 for Surrealistic Landscapes, and in 2006 for Bebop Spaces, and an ACSA Faculty Design Honorable Mention in 2010 for Constructed Improvisations. And finally, we have Professor Flukiger. He holds an M.Arch from Virginia Polytechnic Institute and State University, Blacksburg, Virginia. He teaches and practices architecture in Lubbock, Texas, where he is an associate professor of architecture at Texas Tech University. He worked for several architecture firms in Switzerland, including in the office of Mario Botta, and in New York City in the office of David Rockwell. His design work has been published in the New York Times, Texas Architect, and other journals and magazines. So now I'm going to go ahead and introduce the topic. I'll go ahead and read over the brief, and then we will introduce the first question for the panelists, which then will lead to the discussion. Today, like I said, we will be discussing architecture and the machine. We'd like to first define what we mean by the machine. We understand the machine to be a device that performs a task or job, but we'll be looking at the machine as a way of identifying a process of doing, instead of focusing on a product of the work done. We can best illustrate this through a project by Moholy Nagy, who was a photographer, sculptor, and professor in the Bauhaus School. He developed a machine that produces light that is then manipulated through various filters and lenses which allow the equipment to arrive at countless optical results. This produces and is producing a continued experience in space that allows the machine to simultaneously participate in the process and the product of its function, which then leads us to the project that both the machine or the process of creating and designing and architecture itself can simultaneously lead us to the experience of a built environment. Another form of looking at the machine process can be expressed through a reading from pamphlet architecture number 12, Building Machines. It quotes, "The readings or understanding of current facades are inherently superficial and can only be understood as information, whereas human life, and with it architecture, is predicated on experience. The machines most representative of our time, the television, the telephone, the camera, and the computer, are those that deal exclusively with information and therefore deny all but the most emaciated forms of human experience. In certain contemporary architecture, the real or present movements that result from human inhabitation are considered banal, while the implied or absent movements involved in a mostly inherited machine imagery are considered expressive." From this quote, we understand the machine can be considered as a process of denying an experience, a way of separating humans from a natural process of interaction and leaving the users at a surface level understanding of place. Considering the relationship between the machine and the built environment, in architecture there exists a more distinct line between that which produces an object and an object itself, which then leads us to our first question. Is using the machine as a tool instead of a participant holding us back from the unpredictable outcomes within the built environment?
Could you repeat the question?
Yes. I'll go ahead and repeat it.
Is this supposed to work?
Is using the machine as a tool?
Is using the machine as a tool instead of a participant holding us back from unpredictable outcomes within the built environment?
No.
Why?
Well, you're still behind the machine or involved with it. Well, when I had the call, when I got the email, I thought a lot about the machine, and you're bringing the machine first from the modernist area, and then you're segueing into more a contemporary, but still past, present from pamphlet number 12. So that in itself, I mean, the high age for the machine for me is the modernism time. So when we talk about the Bauhaus modernist machine from the 20s, 30s up to the 50s, that's a very different understanding from today, at least for me. And I think the separation of what a machine is, or what maybe is when electronics come in, I think that should be distinct or distinguished, and I don't know how to do that because we basically started overall with it, but I brought something for you. So. In a way, this is a primitive machine, right? And I would say that's probably somebody could have used that pre-Stone Age, but I took it down there from the shop. So it basically is a tool, right? When we do that as a tool.
I could use this in studio.
You could, maybe sometime. And then I would consider this is the classic, and specifically more this one today, because it ticks. It actually is making a machine noise, and it shows all the little gears and springs in here. You can pass it around if you want. Which we sort of, when we look at it, we can trace that back, right? So it works or it does not work. But then when you look at, for example, an artist, his name is Jean Tinguely, if you can Google that, and look at his machines, he started to really make fun of the machine age, basically arguing. He took scrap pieces from modernist areas and made machines who made nothing. But basically what I'm trying to say is, where we are at, or where you are at, you're here. So basically we have, instead of just a machine, I tried to expand it to the mullet and to the microchip.
What was his name?
Jean Tinguely, Tinguely. NGEGY. So basically, when we use a machine, we don't use any machine at this point. It's just basically mechanical. What we do is, I have somewhat an understanding what goes on in the watch. I have no understanding what's going on in the microchip. Maybe some of you do, but I argue with you, everybody has an interaction with any type of machine at a daily basis. I'm not sure if you are aware of it, how this goes for you when you go from one to the other. And when it became from mechanical to basically just a slab of glass, we no longer know what's going on into the iPad or the cell phone. And I think this is when they make this sort of hybrid, right? They offer me a keyboard who has resistance, not just glass. If I close it, it just comes up as a keyboard to which I can tap on. So I would say, coming from sort of, because of my age, from the Bauhaus tradition to the digital area, I use both, but I think neither one hindered me, to answer this precise question, neither one hindered me to actually, that would limit me, or I could not go beyond that process, and that's how I feel.
When I read that question, I went back to Vitruvius, and I remember that out of his 10 books, 9 are dedicated to architecture, the 10th book is on machinery. And it inspired, this is 30 BC, so it's one of the oldest treatises that we have. It also inspired Ernst Mach to write the history of mechanics that influenced Einstein. In his justification of Vitruvius, why does he talk about machines after having dealt with building, right? And the design of buildings, materials, proportion, the Vitruvian man, it all comes in here. These matters require careful thought and planning by a well-trained intellect, for none of them can be accomplished without machinery and without hard studies skillfully applied in various ways. So according to Vitruvius, the machine, and he talks about different types of water mills and hauling machines, they are the tools we use to construct, to build. And so your question, will a machine limit our building machinery? Is that it? As you call it, or the building machine? I think without tools it would be very hard to do so. So that's for building machine. If you want to talk about design machine, I think that's a whole other topic. Maybe your question is twofold. Would a machine be able to design or limit our abilities to design? And then I will give it to our poetic kind of interpretation of the postulation of a design machine, which has been formulated in the 20th century also, you know, which is a different type of approach. But, so I concur with my colleague, Professor Fluginger, that no, machines are and will not limit our abilities. That's my small experience, where these debates in the 1980s were, will computers take away our ability to be creative? And those debates went on. This is the first mini Mac that I brought in the university, where they were still using mainframes. I was the first one to program on a mini computer, and everybody thought, oh my God, no, computers are not going to be able to replace our ability to design. And if they would see me coming in today with the iPhone, where, you know, I can touch and type on my iPhone, right? I don't need the keyboard anymore. We are in the iTouch generation, right? The touch generation, rather than, you know, I can do everything on the iPad. And he has his keyboard and reading in the same time. So technology advances very quickly, I think. In 20 years, it has, and it will in your lifetime also develop almost without knowing where we're going, because there's a lot of machinery and a lot of design that is going on. So it's really hard to predict where we will be from here in 20 years, which is, you know, that is the machine itself, or design of products in general. I'm not talking about architecture, that's a whole other thing.
the debate is still going on about creativity being limited by the machine. I mean, last year there was a symposium at Yale about is drawing dead, and one of the frustrations that came out of that symposium was that it seemed like the theorists were declaring that some kind of nostalgic view of drawing, and that drawing is dead because of the machine, the computer, and then there were the computer based practices that were saying no, you have creativity with the machine. It's how you use it and how you approach it. I mean, that's a sort of a reduced version of that. So, the debate rages on that level. One thing that I sort of take issue with is actually the statement that you sent us, because I think, especially when it comes to Moholy, I'm not sure he saw the thing that he built as a functional machine to generate light or generate different or let's just say merely that. I think it was more than that. It really came out of, I looked at the website that you had referenced to that, and I also take issue with whoever wrote that thing. It seems like a kind of reduction of what Moholy was trying to do with that experiment. Do you know which website I'm talking about? The one that you sent us the link on the email? The email that you sent us with the statement. There was a link to the space modulator. Some blog, which I've never heard of. See, this is the other part of it, is that, just because the information, there's even commercials about this, just because the information is on the internet doesn't mean that it's correct or it's intelligent.
Informative or valid.
Yeah. And so I remember looking at that and saying, this doesn't, who is this guy? I mean, that doesn't sound like what I remember reading about Moholy's light space modulator. Well, anyway, getting back to what I was trying to say. See, when Moholy was working on this idea, and it took him almost 10 years to build the thing. He attempted to build it himself, and he found out he didn't have the skills to build it. So he actually had to get an engineer and consult with an engineer to figure out how to realize how to build it. And so a lot of what Moholy, or the way Moholy would work, is that he almost worked like an architect, in that even though he was quote-unquote an artist, many of his works were not necessarily done directly by his hand. For instance, there was a set of paintings that he did called the Telephone series, and the myth of that series, it was a series of paintings that were done on enamel. They were enamel paintings on metal, and the myth of it, which he perpetuated, was that he could give a set of instructions to somebody else, like in this case, a sign painter, and the sign painter would produce the piece. And so the reason it was called the telephone painting is because he remarked, you know, that's what he did. He actually went to a sign painter with a set of instructions. They made the piece, okay? And they made a series of them at different scales, too. So he changed the scale in the instructions. Well, he remarked to one of his friends or one of his colleagues that I could have done it by telephone. I could have just picked up the telephone, given the instructions, and I wouldn't even have to meet the guy. I mean, think about that. This is in, you know, like 1922 or 23 when this happened. So, so that was one example of Moholy kind of making the drawings or coming up with the idea and getting somebody else to produce the actual piece. So he did that with the telephone painting and with the light modulator. And actually, there's more than one of these that were built over time. He commissioned to get more than one built. So there wasn't just one of these. The one that you're looking at is actually owned by Harvard at the, what is it, the Bausman-Riesinger Museum on the Harvard campus. And actually, I don't know if they still do this, but once a week they turn it on for 15 minutes. And so the thing kind of cranks around and spews light out. And actually, the way it's displayed is not really displayed the way Moholy wanted it displayed. His actual vision was to have a box made, a room with holes cut into it so that you could, as the viewer, you could stand outside the box and look in to what was going on in the dark box as this machine was doing what it was supposed to do. Now, there were several experiments that Moholy was doing at the time, and really, as far as I can gather, the purpose of the machine was to somehow interpret what he was doing in photograms and to almost make it like a moving photogram, because he was also at the time interested in experimental film, and primarily he was a painter, and so he painted things that were very similar to some of the results of or the configuration of the machine itself. And so once he built the machine, he had no idea what the machine was going to do. So if you can't really say the machine had any function other than to create something that he didn't know how it was going to work. He had no idea what it was going to do. He just had this idea, and he spent a long time trying to build the idea, and finally when it got built and he cranked it up, he was amazed by things that he had not predicted that it would do. So I don't know if that answers the question, but I had to get that.
Well, I think almost any time, well, I like what I learned from you right now, but I also want to say that almost if you think any device and you give it to 1,000 people and we're all individual thinkers, what happens typically is that somebody out there is going to use it in a very unusual way. And I think that's what maybe the producer of the device didn't intend. And I think that shows exactly the creativity, you know, which is out there, which you cannot control that. And I think that's why my answer was so brief at the beginning. No, I mean, it won't limit me. We maybe have this scenario of, you know, movies and things, and I think it was Charles Chaplin who said on that wheel and that movie, and sort of, well, this is the scary part. But we also now in an academic setting, we are not, you can criticize the assembly line and the monotonousness for the work to explore the fourth assembly line, right? It's all about reproducing and all these things. But as the designer part, or the way we see it, I think we are not actually maintaining a machine. But what I say when I understand the machine is from looking at if it works in the classical 19th, 20th century way, I can trace that back and see how that works. When I look at the chip I showed you, I have to throw up my towels and say, I'm sorry, I can do nothing. And this is how your cars work these days. Because once they got the microchip about in the mid-80s built in, what the mechanics now do is, well, I have to go and check on the computer. They can no longer do that and adjust the carburetor or trace things back. They have to first plug in so they know. And I think this is maybe the part we no longer, unless you're a real specialist, an expert, how to do that. Then you're going to get a part and it costs $650 by the dealer, and all the mechanic is going to do, he's going to replace that, right? It's done. There's nothing about listening how the engine goes or trace something back just with your eye, because at least for me it's impossible. There is some microchip in here, and all we got to do is every 2 years we replace that. Think about if your home phone pre-1960 with a rotary dial, that would be replaced every 2 years. It was unthinkable, but it was mechanically working. Right? So there are steps in between, and sometimes I guess I am intimidated about the device or where it is going, but when I look at the electronic machines or where you are mostly will be working, I think you will, as Dr. Bühling said, have a very difficult time to predict anything or where that is going. And then not to mention about, well, there is the machine and then we have some software running it, right? That's a whole different thing. We didn't talk about softwares, we just talk about the machine. So,
see, Moholy approached everything almost like a professional amateur. Seriously, you know, for instance, when he started using the camera's a machine, right?
Yeah.
Okay. When he started using a camera, he considered, you know, he didn't declare himself a photographer. He said, I use a camera, but I'm not a photographer. I don't really know how to use a camera. And he would say things such as, you know, the way the photographers want you to use the camera. Why do we need to do it that way? Why can't? In other words, he saw using the camera as not just a tool, but another creative device that he could manipulate however he wanted to. So, for instance, he did photography without a camera. A cameraless photography was the photogram. It was doing photographs, you know, using photographic emulsion, light, you know, photographic emulsion exposed to light. With, you know, he would expose different objects to it and so forth. He didn't even use a camera to do that. You know, he used all these experiments as in his courses, in what he did with students, you know, it's another example, perhaps that the machine doesn't hold us back, especially if you look at it in Moholy's way.
Yeah, I like what he said in terms of...
Yeah, there's some photograms.
When you're using the machine, I think there's a lot to do how you approach it. Because if you're just going to read the manual of what the machine asks you to do, or the device, as I say at this point, because we don't know which one, then you follow certain steps, but I think we are on the creativity side, so I think that's where it becomes interesting for us. If you're just interested in doing certain tasks and exactly how to expect a certain outcome of what the machine should do, then that's what it's going to be.
One of the things that's a little frustrating when you see some of the images of the photograms is that they really don't give you the full fidelity of what's going on in the image. If you actually see a real photogram that was produced, if you go to, you know, if you're fortunate to see it in various museums and see it up close, it's a lot more three-dimensional and spatial and subtle than what is seen just on the screen here. It tends to look flatter here than it actually does when you see a real photogram produced by Moholy from the original negatives. It was really about a spatial lighting study with very fine gradations of gray and black and white. I mean, I'm just trying to say they were very spatial, very depth intensive. And so again, you know, if you want to put a function to it, a purpose of this thing was now you have that same phenomenon that Moholy was experiencing in the photograms that he did. Now it's moving. It's
spatial.
Yeah, it becomes a moving version of those singular moments. And actually, from my understanding, when he did the photograms, there was some movement to them, because imagine you're in a dark room and you have a piece of photographic paper or a negative on the table, and you set up some objects. You put an object on the surface of the thing, so that's what's going to show up as being white because it's blocking the light. You know, if it's a negative, it's going to be blocking light. And some of the photograms, he flips it so that it's the positive. But some of the experiments, you know, you were moving things as you were exposing the emulsion to light. So there was some motion, it's just the photograph captures it as a static moment of motion.
So what if we start talking about the machine more in the design process and how it has affected, you know, the built environment? You know, we start talking about the machine and maybe it starts giving us this type of experience. But how has the machine affected the built environment in architecture?
I could go in a lot of different directions.
Yeah.
May I try?
Yes.
I mean, machines build buildings.
Yeah, that's why, you know, to me it's different if you say a design machine or a building machine. When we talk about machines can build buildings, they're robots that build buildings, prefabricated housing plans do exist since the 80s, you know, where they're only robots putting everything together, assembly, all the way from the manufacturing plant, all the way from actually, you know, just on-site type of development. And the other question is, how does the machine influence the built environment in general? And, you know, I think we have to go back to the beginning of the 20th century, and the famous slogan of Le Corbusier, a machine, a house is a machine to dwell in, and he erased that, demeurer, because it was too bourgeois, because it had to be a machine to live in. And that very famous towards architecture, which was architectural revolution, has to, I think, comes back to the early 20th century and the modernist era and the belief in a machine as a social utopia or a dystopia. When we think about Metropolis, Fritz Lang is really about the thinking and the doing, the working class versus the thinkers in the skyscrapers, and, you know, this dystopia of the year 2026, as the science fiction is said. Now, we have an expert on Le Corbusier here next to me too, that the machine for living has been misinterpreted quite extensively as to what he really meant. Now, Le Corbusier was fascinated by ocean liners, and that's how he traveled. That's where the CM actually did part of their charters of Athens. It was on a big ocean liners. Nowadays they call them these big ships, cruise ships, you know. But those were ocean liners, and he was fascinated by the beauty of these machines in the industrial period, and also the airplanes and obviously the cars. You know, to him, that aesthetic of the engineer was the one that was lacking in architecture, where, you know, most people had left the countryside to come to the big city for work, and they were following the machine. But they were living, and their houses themselves were everything except this beautiful looking aesthetics of the 1910s, 20s, and when you would, we do not have that information at this point, but if the workman would go back home, he would find himself in tenements or living in streets in city without running water, without proper ventilation, and that is not a long time ago. I grew up in a big city, and I know people that lived in the city in these horrible tenements that were very unhealthy, so hygiene, and he taught that the workman that now had to work, you know, from 2 at night till 6, 10 in the morning, and then there were shifts, and he would have all this free time, and he would come home and find himself in this very dreadful living situations, that it would be a revolution, because they would be working on nice designed machines to make money, but they themselves, like, you know, in Metropolis, would live in the catacombs downstairs. And that's a little bit what he meant with, we need to think about architecture and dwelling and housing in order to resolve all the social problems for the workman classes. Because Le Corbusier honestly has never designed a machine to live in. You know, the Villa Savoie, the Ronchamp, you know, is not a machine to live in. It's not, you know, how it has been interpreted as a machine to live in that type of sense. Which I think was a big revolution later on, the way people actually lived, and, you know, this type of stanza with this unité d'habitation and the housing, which became the program of the 20th century. Anyway, you want to say something on that? You probably know a lot about that too.
Well, I think Corbusier gets a lot misunderstood. He at some point says, you know, like, to be an architect is not difficult, try to be a poet. And with the poet part, it means, like, think about it, that something has to do with writing. That's not really a machine type of thing, you know, like we have the Poetics of Space by Professor Niemann. That's a whole other thing. That speaks to your sensual thing. You cannot calculate or misunderestimate the idea of having a modernist building was also just to have light and have a healthy building. Because baths and all that, and the life expectancy between around 1900 to the end of the last century, it's probably about 25 years. And mostly because of improvements of living condition plus our healthcare. I would like to go back a little bit to your original question. I mean, for the second question. I think, to me, in one word, it's speed. That's the answer.
It's what?
Speed. That's what changed the technology. That's what your question was. And I give you the answer how. Because when you look, for example, a building from Louis Kahn, every Louis Kahn building took about 6 or 8 years. And then it turns out to be such a simple building. It's not really that the building is built by computers. Yes, occasionally, or by robots, rather said. But what I would like to point out is that instead of having to draft and use mail to go to the engineer and all that, simply stuff happens now by the email. And the way you have to operate in an office is so much more quicker and complex. It changed everything, literally. But that's not really what we think about. We usually think about architecture change in terms of, oh, well, a robot built that. I would actually argue the way buildings are built, I would say at 98%, is quite primitive. I mean, it's like, look out those bricks and what they do right now in our building drywall. I mean, we did that 40, 60 years ago. I mean, there's nothing, absolutely nothing changed. And it's relatively a small amount. I mean, when we have some invention, I know in the academic we talk about it, but what probably revolutionized your office work more is, let's say, the spreadsheet, because you all of a sudden can calculate things the way you never could. I mean, a simple spreadsheet. That probably changed it more than, I really see very few buildings built by robots in Lubbock. Even in Dallas. So it's a very interesting part, or in New York, it's a very interesting part, but I have to say that just watching my colleague on my office, I give you an example, using for a project, using the not the laser printer, right? So now he has all of a sudden a project he's tiling, right? Putting one piece that comes out to the next. And all of a sudden he's mostly preoccupied how those two things gonna join. everything is perfectly printed. He's preoccupied in between. Now translate that to an entire building being 80 feet wide by 60 by 10 stories tall like this one. So when I look at that, at the construction part, even though I see things changing, I see relatively little and relatively archaic methods in way we put still our buildings together. However, the design process has changed, and here is where I would like to say something. This is why I brought this up, is when you use this, it's basically very simple, right? I'm extending my genetic force, okay? And tap something, can tap something harder than my flat hand. If I have the watch, I don't know where it is. I would like to have it back at some point. What we see there, we see basically things rotating. And when we see it basically going electronically in the microchip, we can't really trace that back. So I think with the physical impact, the resistance of a tool, before you drafted, when you had your pencil at the straight edge or at the curvular template, it used some technical skill. That resistance no longer exists. And what does that mean? It makes you it makes it more abstract for you. And I give you an example of one student in a semester long, long gone, well, shall remain unnamed, but basically the student said, well, you know, my shop class, I never drilled a hole. Well, I think that's an important part, but when you do that, you actually feel resistance when you do that. If you tap on this glass, there is absolutely no resistance when you tap on this keyboard. You also maybe noticed that Apple came out with a special keyboard you can attach to it, which then lends to give you a little bit resistance. Okay, so I think that's the interesting part, because there are some of us who are interested in that. Interested in our hands and what resistance that offers. And that wasn't anything bad to say that the student for the first time drill a hole, but that's exactly a mechanical experience. And your experiences right now in design studios, they change so dramatic that they mostly have no resistance at all, right? And it tells you something because you react on the machine. Right, you maybe get a new computer, so your keyboard shifted a little bit. Some of us notice font on those keyboards and things like that. But the whole thing is relatively minimal, and I think that's what basically sort of distracts or not makes a distance between the built work. And I think then to expect that the building is being printed, components maybe, but I think that's really something we have to. I mean, it's fascinating for me. I'm thinking about that a lot, because I think that does make it somewhat more abstract the way your education is than, let's say, even just 10 years ago.
Yes and no. Yes, you have a question.
Oh, I was curious to hear then, and from anyone on the panel, what you would begin to distinguish if there's a mechanism to the machine prior to electronics, and then electronics introducing an absence of space. How would you begin to define what type of category of machine is that? Or like, what does that start to become?
It made me think all spring break, because I went to Concord, Massachusetts, and they said, well, we have a reproduction of Thoreau's cabin. Henry David Thoreau lived before Civil War, went 2 years out to Walden Pond and built his own cabin. Original cabin is gone, they made a replica. Okay, so it's too short, story short, and then said, you look at the replica, and all of a sudden you see, well, there is a galvanized nail in the replica. There's a 2x6, a 1x6. Did Thoreau have that? No, he had 1x as he described it. So where do you do that? Well, he had a tool, but then we tried to reproduce it. It is a very, very hard thing, in my view, to say, well, you go back and reproduce that. Or in a primitive way, that is a tool, but you also notice now we have what's called power tools, right? Putting in a whole different category. Probably have even a microchip in there. Anything after a 1985 can have a microchip, even a power tool or a table saw. So to me, that's something I think about.
You want?
Yes and no. I think technology allows you, with its developments, to have different performances of the Ninth Symphony of Beethoven, but the Ninth Symphony of Beethoven is the Ninth Symphony of Beethoven, and there are different performances that are possible. So whatever your new tools, when it goes about building machine, that would be different, be it with a nail or with a hammer, or growing up in arts and crafts, and there was no electrical tools used in remodeling a 17th century, Spanish brick building versus the power tools that would not be allowed. So there's that philosophy one end. But when you talk about design machine, to answer a little bit that question, that you think about how to compose a building, how to design as a composition, as a score. That requires different tools. And, I think the light machine is a metaphor. And I think as artists, as poets, we can use any tool outside of the prescribed way of using the tool. You can do that with cars, you can do that with airplanes, we can do that with photography. The way we use any kind of tool, it's up to us to be creative about its use. For computers, there's the GIGO, right? Garbage in, garbage out, saying of Bill Mitchell, whenever you put garbage in and garbage out. I've personally not seen do really creative design. We draft a lot with computers, we do a lot with computers. I don't necessarily think it's already a design machine, that it can provide us with intelligible solutions in the design, in the visual spatial universe, which is the realm of formal design composition. That is pretty stuck because it's so complex, and the brain is and our perceptual, what designers do, computers cannot yet do, that is a little bit going into this cognitive, which is a kind of a formal theory where the idea is, can a computer simulate what we do, which is really designing, based on perception and receptor, but the processing of design. What is it really what we're doing as designers when we do what we do? And that is a really hard one to capture, which is probably became even more conscious of how we design prior to being able to, kind of formalize it, which is this kind of research that's going on that level. And that's not clear, that's still not resolved. Because it's visual, spatial material, and it's not symbolic material. And computation on symbolic material is literally one-dimensional in strings of symbols, whereas spatial material is multidimensional, and we still flatten it. Because after all, what we see is a flattened image on a computer screen, no matter what you say. I disagree a little bit with the tools. The experiment in studio I did is with going from a flat, two-dimensional realm and sending it to the laser cutter and taking these pieces and putting them quickly together. I think it's a very successful experience that, unlike Alberti, who said, an architect is not a carpenter. We think and the carpenter does. That machines now, I find it a great freedom. I can design and actually print it out and laser cut it and assemble it myself. Rodchenko did that in 1920, and we're almost 100 years later, and we just do it now with a laser cutter, and it's done very quickly. And I think that's a liberation of knowing that as architect, you can think and do, to a certain extent, much faster than all the different steps. So it makes our lives easier, which is what technology is all about, I think. So,
yeah, I think it never made it easier. I really think it only speed up the process so you could do more work. And it will go faster. That was my point with the Kahn buildings. And I think I totally agree with your point that when you can print out something, I'm the first one to use that, but I would like to make a distinction. There can be the architecture who is not in a built form. Let's say you have even a 2D drawing, and I can consider that architecture. I can refer to Piranesi and others. But then also, the one architecture I was talking about in terms of robots building buildings, I really was talking about architecture in the sense making spaces to use for you to live. That's a different moment right there. Now I would fully argue that yes, if I have anything printed out on a 3D printer, that can be considered architecture and it just stays at that scale. I think once it becomes an architecture of a full-size one-to-one building, I think that's when we have so many things unresolved, and that's when we have a relatively still common archaic process of building those things together. And I think that was my main point in terms of robot buildings, currently buildings.
I think I tend to agree more with what Hendrika said on this. You know, I keep thinking about my own experience, and you know, back in the day, I was pretty good with a rapidograph pen. I mean, I could probably outdo anybody in this room with that. And,
shoot him.
Yeah, I mean...
Maybe not.
Maybe not.
I mean, I wasn't just good, I was damn good. You know? I mean, I was really good. And
I was good. You were good.
I mean, I wasn't as good with models. Models I wasn't so good, although I had my moments, but I was better with the ink drawings. You know, and I always used pencil as the kind of construction of the drawing, and then would progressively ink it. I'm not nostalgic for those days. I did it, I was really good at it. I'm thrilled that I can use a computer to do all that stuff now. And over spring break, I was supposed to be working on a paper, which I really hate doing, and I'm still working on it, and it's due in a few days. And instead of working on the paper, because I was, I don't know, I received, every few months I received these newsletters from Yale, and in the newsletter they had the thing about, they had some blurb about the Drawing is Dead symposium again, because I had known about it, but you know, I don't know, they were reporting on it, some more information. And so I found out that some of it was on YouTube. So I went to YouTube and I was listening to some of it, especially the part where Greg Lynn was speaking about it, because I had corresponded with him about some of what went on. And that inspired me to do some drawings, but on the computer, you know, in resistance to this nostalgia to, you know, touch the piece of paper and feel the resistance and all that kind of nonsense that he's talking about. And I had a great time. I did, let's see, in 5 days I did 5 different drawings, and I really miss that. But I did it on the computer, and it felt the same way that it did when I was back doing it, you know, the old-fashioned way.
Hey, listen,
no, I need to clarify something.
Me too.
No, it's my turn. You two spoke.
See, and I also.
No. I mean, you misunderstood, because the point here is.
Yeah. See, I also agree that architects are not the ones
your turn,
that
it's mine.
Nobody decided.
The thing is, all I try to illustrate is the history. I didn't try to say this is what I have or want to do.
Yeah, but you're a design build guy, so you're kind of into that sort of stuff.
Well, I feel very misquoted by you, but go ahead.
Okay.
So what I'm trying to illustrate, let's say there is Gutenberg around and he has the individual printing coming out, and there is still people doing, let's say, calligraphy, and they're going courses, and like monks or legions of monks got like broken backs because of doing that. Right? There's still some of that here right now. You can go and enroll in some course. All I try to point out that when technology evolves, you really can't go back. It's just something I noticed, that when it comes to the building part, because in order what the setting is of the class, when the student drills a hole, that was actually something the student had to do because he or she choose that particular class. And I noticed that there is a difference between students in the past and now, because to them that's more abstract. That's all. That's not me, that's not personal, that's something I observed. And I think I would be the last person who would go back and say, well, I make you draw this by hand. No, absolutely not, because I think it makes no sense. You have to accept the time in which you live. And you need to think forward on that. And in that regard, I feel very much misunderstood.
But what happens when that technology fails and you have to resort back to hand drawings, and the newer generations don't know how to do that because they've only been taught with the new machine?
May I add on to that actually? I'm glad that we started like getting away from the machine and like, you know, just a technical like CNC or laser cutter, but by like integrating human interaction with this. Like, you know, of course, I agree, sure, technology is very convenient, but how convenient is it when I just heard you, Professor Flubiger, talk about in Professor Park's reviews, you know, technology like iPhone, iMac, iPad, but we reference these like technologies, but let's say that it's stopped working and iTunes syncing doesn't work. Like we don't, you know, we reference back and we have to go get a new one or depend on someone else to fix it. And so that basic understanding of how these machines or systems work and the importance of it, especially in like our generation, I think is a question. And it's weird and clever because essentially a man made that machine though. Like someone designed that iPad and iPhone and stuff, but you know, it's just this sort of design. Like someone designed this microphone or someone designed this, you know, the screen. And to me, like it goes back to design. And so, yeah, how important is that understanding?
In 1980, the Macintosh SE was estimated to have 30,000 man-hours of research in order to develop and design that machine. And IBM took that and then made their, what was the IBM PC.
Yeah.
And they ran away to make it a big business. I think now we have the iPad and we have the Androids, and the same thing is going on with Mac. You know, there's this kind of a question that, you know, technology will go on and we cannot replace with one person what so many have put in there. To answer the question, if your power falls out and you can't use your computer to draw what you do, it's going to be pretty much up to you. And I'm going to try to get something in here from a more feminist perspective and ask you as people, because we're talking about architecture after all and residences, and in a certain way, if your laundry machine, who of you does not have access to a laundry machine and a dishwasher and what is it, the heater, so you have the washer and you have the dryer? Yes. So I'm going to ask you, and I will get to that because it deals with architecture also, people, I think, to understand what architecture is. You know, if you don't have your laundry machine or your dryer working, what are you doing? Are you going like your grandma? And 100 years ago, that's exactly what it was. There were no laundry machines, there were no dryers. Wash was done on Sunday evening and the whole day Monday. And ask your grandmas or great-grandmas because you're the 90s generation. And so cleaning, cooking, child rearing, these are all activities that women do in a house. It's part of, you know, architecture and that was not available. Now you take all these machines as, you know, the American kitchen, you take them all for granted. I come from the old country where it was not for granted. In France, when you talk about the French kitchen, you talk about the cuisine and the food you eat. The American kitchen is the appliances, right? And now you have all microwaves and all. So what do you do when that machine fails now? And the same is true with your computer. You know, here we have experts that are trained in our tool by drawing by hand. And if we don't have a pencil, we use another pencil, we use another ink, and we changed our tools. But listen, we were experts in our tools, and you know, you never replace a human being in its expertise in using their tool to get his ideas out. That's all I want to say. Yeah.
I would like to answer your question a little bit, because this is, I think, I think the world changed. It's so much more complex for you. If this breaks, right?
You buy a new one.
You buy a new one. That's why we have the 2-year contracts. We buy a new one. You get some mechanical device, let's say some candy machine, or sometimes you can see that American Restoration, I'm not sure how many saw this show. So the manual is already lost. Some guy brings in an old machine from the 50s, 30s or 20s. He looks at it. He starts looking at the mechanics and he can fix it. And that's a skill, because he really can that. And he starts to operate, and this is what you see when you see the watch. You could give it, send it to Switzerland, not this particular one, and they would fix that. Your world is way more complex. You can't do that. And this is what I'm trying to say, is this is where you have no access. I have no idea what's going on in here. I just don't know. And what that then basically means, your world is so complex and will even become more complex than when you try to interchange that. You cannot do that. You just cannot fix it. So you will have somebody who bring you a whole new component. And the way those were designed is basically an enormous amount of people, and when it's turned off, it's even black. You cannot even know whether it's charged or not.
And I agree, it's going back to the laser cutter, right? Like, we cut squares out of the laser cutter.
It is.
And, you know, we default to MDF because it's available for us, right? But then are we really testing as architects? Like, we're learning, right? And going to college and stuff like that, but just having a laser cutter cut that square for us, and just like us doing it, are we really understanding that joint? Or are really understanding, and to me, like, yeah, that's very basic, but does that not play a larger role spatially in like the way our buildings function and work? Like asking those questions, that understanding, you know?
I think let me make a comment. I'm going to try to explain what I think you're saying, okay. So I'm going to try to speak for Jacob. In terms of the evolution, we're talking about evolutions of technology, essentially. And the evolution, in my opinion, is important in terms of a question for you. And that is, the evolution of these tools, are they changing? Well, one, they are changing processes. And are they changing processes of new formulations of product that we weren't able to acquire or to get to because of the evolution of new tool sets? So that there's a direct link to products of our environments by the changing nature inherently in the tools. In this question is also, sort of what you were saying, but in this question it's also in terms of processes. And are the machines operating, and I work with these guys, so are the machines operating as a tool in a design process, or are they operating as a participant of that process, which in fact would change the evolution of the products by the tool sets?
I think that it's not much of how the machine affects us, it's how we embrace the machines. I come from a Latin American country, and the whole thing about the dishwasher, we don't embrace the existence of the dishwasher simply because it's not how our culture goes. We wash dishes by hand. Same thing with the machine. The limits are not set by the machine, but by the people that embrace the existence of the machine. It's how we view the machine. It's how we see microchip in other countries, geographically, demographically. Other people would say, wait, hold on. How can we fix this microchip? How can we fix the iPhone by ourselves? In an American society, let's buy a new one. So I think it's more of a urban take on the machine rather than the machine taking on us.
Can I have some time for Dave to answer my question?
Your question is, does a machine allow us, or would it change the forms and designs we come up with? Is that correct? Well, I think that's what Moholy-Nagy did, and that's what artists are doing. When Picasso realized that there was photography and other painters of that early 20th century, there was no more need in object painting, and they moved on to abstract painting. And later on with Marguerite, we came back with surrealistic painting with the symbol and the sign, and and it was object painting. So that's the poetic approach. And I still believe that, in life there are the poets and then there are the physicists and pragmatists that explain it. And Art and Physics of Schlein is a very good book in that sense. You really do not know if it's poets that are working on the limits of our knowledge or of our creativity, and that they prefigure poetically what the new reality would be, creatively speaking. And then you have the physicists who, somehow kind of start looking at, what is our meta model, that how we can understand the world afresh or anew. Because also, I think machines are evolving, but so is science, or at least our interpretation of it, our consciousness about it, and the theories that evolve. And there is no unique answer, and as long as we're human beings, we will be both pragmatists and poetics. And we have poetics of machinery, we have the pragmatists, and we have those two different approaches. I think about Boulez and Ledoux with their visionary Piranesi, Boulez, Ledoux, and if you think about Boulez and his cenotaph, that was not performable at that period. We could not build a spheric scale on that size that he presented. The Géode, our attempts, because it's one of the most difficult structural things to build, it's the perfect sphere. But it was, prefigured in Boulez's visionary architecture, and it was considered to be very valuable. So my answer to you is, don't try to exclude one or the other. Don't think it's one or the other. I think it is both. And, that's part of who we are, and that's why, this is the biggest computer that will ever exist. And this will go further, as much tools as we have. We're just evolving. And I don't want to know how a space shuttle is built, but I still would like to sit on a space shuttle and visit, the moon, for example. Do you understand? We can't do everything. It's a cumulative knowledge that's embodied in some of these machines that, makes us do things differently and perform them differently, and technology allows us that. But that doesn't preclude that we cannot be visionary and do something that is performable only, and that's what design is. Design is that it's unbuildable as of such. This is what, 18th century? I didn't predict, but look at the scale of that thing, and that was unbuildable. But that's design, and that's why I'm saying there's a difference between design and builds. And I think that's when we can start understanding two different approaches, because they're a little bit different. In Europe, as long as it's unbuildable, it's not considered architecture. But this is just the opposite. This was unbuildable and has never been built. Just a model in the belly of the architect. Is that a movie that they made? Okay. But look at the scale of this time. But
there's someone I would like to put on the screen, Bill Massey, an architect, and he did a house called the American House. And it starts to straddle Massey, M-A-S-S-I-E. And so what he executed through the American House, well, he graduated from Columbia, I think in the 80s or 90s, like completely obsessed with the computer, and then the way that the computer starts to shift or change architectural space. And so with a lot of these studies, or this is a house completely made of materials from Home Depot, so off the shelf American products, but the way that he configured them was with a super laser cutter in the back with large 4x8 sheets, and also laser cutters that cut steel to start to reconfigure joint connections and aluminum framing for the windows and some of the relationships between the beams. But if you talk to him about it, he's also quite honest about the limitations, like the effectiveness of the actual assembly of that. And I feel like there's this fundamental difference between, and starts to talk a bit about what Jake is talking about, and then I think with Jeff, you were referring to the method, like the product output. If you have a machine that flattens space and actually like bypasses the relationship of material resistance and limitations, it does set up a different prescription of architectural assembly than if you're working through machines where you can test or manipulate or understand how space engages. So the system of the watch, configuration of gears and layering of those gears still has micro space in between the material. So there's still a layering of material and space and performance within that, where as soon as you go to some type of interpretation of an electronic system, there's no space. It's like zeroing out space. And it's just nodes and energy running through material. I think that actually does set up a limitation of what could be the product. It does begin to script a difference of performance in architecture. But actually, I would have to say it doesn't directly relate to how the machine's used culturally either, because if there's still there's a capacity of interpretation, so bypassing a washer or a dryer, or just doing it more by hand because of efficiency, or that sets up a different limitation of how a machine might be interpreted, but it doesn't necessarily negate the difference that there. I still see fundamental differences between a computer production and being able to work within the space or observe the spatial. Actually, going back to being able to appropriate the machine. It's much more hard to appropriate electronics than it is some other mechanical machine.
You're talking about generating a design in a computer which is a pictorial space, which is really flatland. And it is, or in drawing for that matter, there is a big realm of difference between that and actually the world of the three-dimensional space of haptic and corporeality, where bodies get, they are either solid or void. And there is a big world of difference, I think, that, and this grows a little bit, and it's a very difficult one. When, at the height of the computer revolution, we could all draw with computers. In the 1980s, I remember all the, engineers being happy that finally, the first time they saw a polygon on a screen being traced, a polygon. That was 1980s. Nowadays, you generate designs all over the place, with Katya and I remember a time AutoCAD was not existent. But it is a virtual world, and it's a pictorial space. It's really a two-dimensional, non-material, abstract space. And there is a world of difference. At the height of that, when Franklin wrote the rappel à l'ordre towards the tectonics, it really meant it's time also to deal with the corporeality, because a plane has a particular thickness, in how do you join two things together is quite different when you do in the real model building rather than, and that's why architects build models as well as, generate two-dimensional graphics. If you ask Frank Gehry, Frank Gehry designed his fish, and he has somebody else, who designed it two-dimensional, but he works in physical models too, where you have, it can be very limiting, because thinking abstractly in three-dimensional space is rather difficult. We're so used to the haptic, real-world experience of three-dimensional space that it's really hard for us, to think abstractly in that. Anyway, and that's where the new algebras, they distinguish these different dimensions of space, and the pictorial space or the abstract mathematical space versus the one that we can represent, and it's always two-dimensional, and which is image versus the actual making of the thing, because then you have thickness and it changes your whole way of thinking. And I find that maybe where we are right now with having both computer, and all the students know Rhino, and Form Z or any other. But it's object modeling. It's not modeling, they really can get through the two-dimensional. It's much easier to start merging and overlapping and designing with all that and reinterpreting that, but putting it in a model and going back and forward. And again, it's not either or, I think it's both. And it's a transition from one medium to the other, one machine to the other, one tool to the other, that provides different aspects and different approaches to its design. And I think it's the tectonic and the realization that that was different from, you can never generate that on a computer, the virtual world. And you cite a good example. I know in France they were designing this bridge in Orly, and it was well designed and overly designed, but actually the build structure was under calculated, and it collapsed. And so from that time, people are kind of, wait a second, what we do there and what we simulate as structures is still only a simulation, and it is not necessarily the same thing as the real world object of the tangible world, the haptic world. There is still, that translation is still one that, between the abstract pictorial world of the retina, but also of the screen and the image versus, the haptic world and how it will perform. That remains, remains a simulation. It's never a real thing.
Thank you for that. I was wondering if I could answer maybe your question and a little bit of Jeff's, just because Frank Gehry is on screen. And I'm speaking here as an art historian, not as someone who has any architectural knowledge in any way. Mankind has always, I think, had an anxiety of in making and use of technology when we lose control of it. And I'm just thinking that, let's say computers and its use in architecture. Frank Gehry being a very good exponent of how computers has entered architectural practice in a very deep way. But what does he come up with? These giant buildings of fishes, right? Which further sort of enfold us in the society of the spectacle. So where we become even more enchained and a greater level is his building speaking to a kind of globalized hyper-capitalism that we end up being caught in. So I think the question that's kind of at stake in what you were asking in relation to or if I'm using a laser cutter, am I not being educated as an architectural student in some way, losing touch with that same tactility or whole kind of technological practice. Maybe that's not the right question. The right question being, when do we get to the stage in our use of technology where it slips beyond our control? It's kind of it's maybe it shouldn't be an either or, yes technology or no technology. Rather, we should attend more to how we interface with technology and the various ways in which we connect to and disconnect from technology. And technology, there's the whole question of uptake and whether we use technology in the right way, whether it fails us. But then, it has all these feedback kind of relationships as well, right? We get so used to our iPads and our iPhones that we kind of forget other ways in which we, let's say, we react to the world or react to other human beings. And maybe these feedback effects are at the societal level as well. So if I were to have a solution, I guess, to this problem, is that we should attend not in a yes/no manner to technology, but focus more on the different ways in which we interface with technology.
Can I say something? I don't know what other people do. I know what I do. That's the only thing perhaps I can relate to. I'm sitting here with my iPad looking things up as I go along, and actually I'm not looking things up on the internet. I've got my own personal Google machine on here, which I started in 1983. which is when I started teaching, which is when I got my first computer, you know, which was right after I graduated from grad school. I had this idea when I started teaching, you know, I had to write up syllabus for my classes, and I had to type up assignments. And so back then, the best thing you could use was a typewriter. And it was even better if you had a IBM Selectric typewriter, because it had a magic key on it with an X on it that allowed you to go backwards and correct with some kind of built-in white ink, erase what you did. Now, you know, that was good for a letter here or there, maybe a word here or there, but if you had a whole sentence, it got pretty, you know, it didn't look very good. So when I started teaching, I didn't have my own IBM Selectric typewriter, because that thing probably costs a lot of money. And so I had a key to the department office, and the secretary had one of those, so I'd go in after hours and type up my thing. Then somebody on the faculty said, hey, you know, we've got this computer up in the library that you can use. It's a Trash 80 Radio Shack, TRS 80. So I started going up to the thing. The only problem with that is it did all the letters, all the characters in uppercase. It didn't have lowercase, and it would print out on a dot matrix pen. So you know, and that was a phenomenal thing to use, because it was much better than the IBM Selectric. It looked uglier, the printouts looked uglier, but it was kind of computery because it had the little dots and all that kind of stuff. Yeah. So that was okay. So, you know, I'd get them Xeroxed and hand it out to my students. I mean, I had no idea, maybe students now think it, I had no idea how to teach that first year, but, you know, I pressed on. So anyway, by about, you know, after a few weeks of using this Trash 80, I don't know, this was at North Dakota State, by the way. These guys in blue suits came out, they were from IBM, to sell us on the new IBM PC. And they told us, we can get you as faculty, we can give you a special deal, we can get you this machine for $3,500 if you buy it today, because it actually costs $4,000. You can get a $500 discount if you sign today. Oh, that sounds great. I didn't have $3,500. The only problem is you're not going to get delivery of it for 9 months. Okay, by the time it came out 9 months later, it was $3,500 instead of $4,000. No printer, that was extra. No software, that was extra. So by the end of, you know, that first quarter that I was there, I started looking for. I needed to buy a computer, and so I found a computer that had software, that had a printer, and I got a loan, and for $3,500, I bought myself a computer. It wasn't an IBM, it was something else. It was an Epson. And that's how I got started with computers. So going back to my Google machine here, I had little index cards with little notes that I had taken when I was in graduate school, of, you know, different readings and different ideas. I had stacks of these things, and I thought, wow, now that I have a computer, I can put all this stuff into the computer. So I started putting typing my little notes into the computer, because it had the software that it had a database software. And so somehow you could, they would call it a tag today, but you could give it a title, and you could have a little, the only problem was it was limited to how many characters you could put in the data. And later on there was some other software you could put more fields and so forth. So now my Google machine has 12,000, I have 12,000 notes on Evernote, and it's available to me on any of my devices. I can look it up on here. I can look it up on here, I can look it up at home. And so, you know, I put in a search for Moholy, and here's what I got. It says Moholy Nagy painting. Remember, the painting comes first, then the theory. Piet Mondrian. And that precisely defines the way I approach things, is that I do it first and then I come up with a theory.
May I tell something about the Frank Gehry, because it connects with it. Frank Gehry was a very classical trained architect and in UCLA, and he had built his...
I thought he was a jazz trained architect.
His very first buildings are really design built and immaculately tectonically detailed. And he was also a sculptor and does freehand. You know, loved to draw, and actually that's really wonderful. And he made this fish. And the fish was a sculpture that he would sell. And because he liked to be a sculptor also. And then people liked it. And it's because people liked it, they said, well, make a building out of that. And so but it was through models and models. And he hired experts in Katia, I think, to actually model it on a computer. But, I mean, he was a designer all along, all the way from design build, very classical, being, you know, making his fish. You know, not that fish, but it was a sculpture as a sculptural element.
It's actually in the Walker, she's talking about in the Walker, Minneapolis, in the garden.
And this was before
to the right. You had it there, to the very right, second.
And that was in the 80s before he started.
Second, there it is, yeah.
I don't disagree that Gehry is highly skilled, I guess.
Well,
what do you mean highly skilled?
Let me inject something here. I think Frank Gehry, I'm fascinated, but I'm also fascinated that he does his drawings and he has this army of people interpreting that and using exactly the technology you're talking about for building it. So in a way, I think he's actually not that interested in the technology. What he does, he uses it and his hundreds of collaborators to actually realize his forms. And that brings the short answer, yes, it will change whatever you use, how your outcome of your project or what you're going to do. It will change that. Now I would also say something in terms which is basically more literary. I mean, if I take the example of Don Quixote, so you're fighting windmills, you know, like any times you're trying to do that, it became this symbol of basically fighting technology. And once I read that book, to me, just don't do it. I mean, keep at least an open mind. You maybe don't really want to do it, but keep an open mind towards it. And I think with anything coming out, but think about this is an example which fascinates me. So Professor Niemann has an early computer, and now you're going on and we're talking about the most sophisticated, or one of the more sophisticated things we have right now is a tablet. And maybe you discuss this in 30 years and say, wow, you know, this crude iPad I had back then. Who knows what it's going to be? We have simply no idea. And I think that's what I try to say in terms of the open mind. So yes, the forms will always change, and in sort of trying to fight windmills, I don't think that will get you anywhere. Now when it comes to the design build, or if you actually are interested in making buildings that they actually stand, you have to work with constraints. And I can give you an example. You know, if somebody comes up and says, well, we have 2 old buildings downtown at the art district, would you be interested to make it a gallery or a residence? I said, well, gosh, I really don't want to touch that because I want to do this slick thing with all these latest materials, you know. I'm going to dream that up. No, I'm going to reject that. Because he wants it to have right now, I have to start working right now, and the budget is this. So those are basically the constraints, and I think to me that thinking happens also right ahead. So all of a sudden the constraint is, well, in our cabin we work with our students, and what can we currently produce? So maybe the outcome is sort of a crude low-tech design-build cabin. Yet I accept that as a constraint. It doesn't bother me a single bit, but I'm interested in actually having a physical building and in showing them. And I think that's why I think it's very important that you think case and case, because you don't think, well, you know, like I can't get the latest technology in, therefore I don't do it. So maybe there you go more the Piranesi way. that you basically are not interested in building at all, which I think is architecture. I admire Piranesi. So, but I also would say that people like Antonio Gaudi, who basically use round forms, it didn't stop him that most people were doing square building during his time, right? So it also has to do with the creativity of the human being. So he had to get those forms out, even though it was very hard for him to do. Yet that's the one thing he was really driven to do. So in a way, you will have to do your answer and say, well, you know, what are you interested in? And that will be your decision. And that when it comes to design thinking, which to me is everything, if you can think what you're going to do, I think then you're successful.
Gaudi is different in that respect, though. He's not just visionary. I mean, most of his very random shapes were actually made, you know, by these cables, and you know, which they use right now in engineering, modeling on a computer. But the shape was derived by physical models that were inverted for pure tension. So turning them around, it would be pure compression. So he had a methodology, a method, and a process of designing that made it feasible. The Sagrada Familia is just now being completed. Like 2-3 years ago, it actually is, you know, completed. So it took a long time. And it's not just the form or the shapes, be it curvilinear or straight edge. I think there are different ways of experimenting that. But you don't need a computer to make innovations in that sense.
If I would like to even open a new if you want to get a counterpart to no, keep Gaudi up there yet, but if you look Adolf Loos, I mean the discussion between Adolf Loos and Antonio Gaudi, if I see them somewhere in heaven, I would like to sit in. Because they have very different ideas on how things have to be, and I think that's what we are today. I mean, you are different. And there, I think Adolf Loos, Loos, L-O.
Put him on there, there he is.
So when you see that sort of box, and they made fun of him basically being sort of the minimalist at the time. So he's a little bit younger, but think about that. That's a total different aesthetic and different value principle. And all I'm trying to say basically, their technologies were similar. Yet, however, what they tried to do is because they knew what they believed in and therefore gave that architecture shape. And I have for the same amount of respect, but I think that's what I try to instill in my design studios. Don't follow the followers. Try to think of what you are. I mean, the individual. And if you don't know, I think this is the hard part. Then you need to start looking for it. But in terms of that, I think yes, we have way more possibility of what we can do in terms of complexity of shapes and space than we ever had.
I have a question for you guys. I want to go back to, kind of taking notes here, I want to go back to the machine's position in the design process. We're reading the book called The Thinking Hand by Giovanni Palazzo. Yeah. And it talks about how we have a filtration of our design in our mind, and making that filter, you know, go through our hand onto with a pencil, pen, hammer, yes, you know, any type of tool, and you know, our mind is telling our hand to release the lead or the ink that we are, you know, this tool that we're using, or the machine. And my question comes to is, does the tool of the actual machine, like a computer, and which is a tool for, you know, the design process, take away from the experience of the machine in terms of the architect or architects being initiated, yes. And does using technology take away from the experience of doing and being with the machine?
I think you're saying, and I think that's a big mistake, we don't think and then design or draw. We draw and we think thinking and doing in design go simultaneously. Design is a decision-making process out of chunks of information. And, you know, it is shown that cognitively we can only deal with 7 bits of information, and the definition of what a bit is comes later, simultaneously. We don't think, I think we have a very limited imagination when it comes to visual spatial material. That's why we build models. That's why we make drawings. And it changes our perception. And we see new things. And we see it from a different perspective. And so it is a process between thinking and doing and thinking and doing and producing. And when you make, why would a Frank Gehry or even a Frank Lloyd Wright at the age of 90 still have to draw 100 drawings to try to get his ideas on paper and dialogue? It's an internal dialogue with, you know, the model he builds, what he thinks about it, how he perceives it, and how he processes that. So it's like, and that changes, you know, how you resolve, because design is making a synthesis of things. And so it's not that we think and then we're going to put it on computer. You're a drafter, you're not a designer. There's a big difference. That's what I, you know, or model builder. You know, these model builders, the Swiss model builder, I'm sorry, I shouldn't have said that. You know, you have a little design and you make the little train models, you know, or that's not design. You know, because we design and we use this as a tool. We make models in order for our own design process to become better. So it's more dynamic than that.
Here is the short answer from my perspective. It works 100% for Juhani Palisma, because that's what he wrote about it. And when you look at it, if you sort of look at it and Google him, you put him in the phenomenologists of architects, right? Because he's thinking with the hand and the materials and all those things. So that works for him. Now, between him and you is probably about an age difference of 40 plus years. So all of a sudden you start to think that in a context, and I think this is the dangerous part, because when we talk about how do we come up with our ideas, that was his way. And this is what I tried to tie in earlier. What is your way? You maybe don't know yet, but sometimes what happens in architectural studios, that methods, especially for famous architects, are shown. And then all of a sudden, I can tell you, maybe for some person who has sort of, let's say, a similar disposition, it makes total sense. And for another person who has all ever seen is digital devices, that means absolutely nothing. Zero, nada, and would be the worst thing for that person to do. And I think this, each time when it comes to a studio who is, as I call it sometimes, dogmatic, just allows a certain way to do certain things, I'm always very skeptical. Because I have no idea when you come, for example, in my design studio, who you are. And for just telling everyone to do certain things a certain absolute way and to tell you that I would know about this, in my perspective, would be considered a very maybe overbold statement. So when you start to talk about, well, how did you come up with this idea? Frank Gehry being in the room, I remember one lecture with Frank Gehry, and I was very impressed because I had always, I'm not particularly interested in what he does, that's just me. But what he said is like, okay, and I was at the lecture, and I was there and says, well, okay, you know, I wanted to design a chair. But I had to also give him the challenge. It needed to be the lightest serial produced chair at the time. And before he started to design his chair, he basically pointed out to Italian designer Gio Ponti. And it was a very 50s minimal chair, and so he beat that, and then he had his chair there out of bent birch wood, and it was lighter. And it totally looked like Frank Gehry, and I have to say I had a tremendous respect. Not only evaluated or re-evaluated he the chair, he actually pushed it further. It didn't look anything like Gio Ponti's. But what I mean with it, he made it his. It's his form language, it's his personality, everything. In addition, he went so much into it that he had understanding the process of making, that he was able to give it the shape, probably with help of others, that it would look like a Gehry chair. And to me, that was very impressive. So again, if that's a method, I think you can't take any, at this time there is no truth out there just for everybody. You have to just investigate what is right for you.
You're never going to win a competition because you used Form Z by itself, unless it is for Form Z. When it comes to architecture, And, you know, what is the goal ultimately with what you want to achieve in architecture? Which I think brings me back to, you know, machines, you know, in the early 20th century and the introduction, the diffusion into, you know, the household made our life as women much easier, and even yours. And ultimately, you know, that's the reason why we have a suburbia and why we can sit here, and it liberated us for a lot of things. Nobody is going to award you a big project because of the tools you use. I mean, internally, that's important for us as a profession, but it is what, you know, it's one you have what you can conceive, what you can represent and visualize, and then ultimately, because they're conceivable abstract worlds in design that we can as of yet not represent. And maybe that's part, but which could be represented later on. And, you know, that is one avenue of exploration in design machines and algorithms. And this, you know, is there still conceivable universes that, as of now, for example, a four-dimensional hypercube, we cannot really, we can conceive of it mathematically, but we can't really represent it yet, versus then the performing, which, you know, the technology available in order to, you know, develop a Boole kind of Newtonian cenotaph or something like that. So what is conceivable abstractly versus what is representational, what we can represent, versus what we can actually manifest at this point based on our technology, are three different realms that we kind of can explore. And then we, you know, you have to situate where it is. Now, in European training, you could say that if a building is not buildable, it's not considered architecture, and that's how, you know, we were trained. Now, in on the West Coast, you know, you can design and it's unbuildable as of yet, but it's certainly design. And then there is the idea of what is conceivable and not even at this point representable. And I'm waiting for new tools, you know, that can represent movement, like film and all these other kind of things, and maybe, you know, even hyperspace, or, you know, the 12-dimensional space of the universe, that holographic space, you know. And then we're with Patrick Purcell and MIT, who did all this research, you know, in trying to be able to, you know, use machines to represent more or capture more as a receptor and as an effector, right?
But I think that, the word representation is, I think, a strong kind of play here. Because in a lot of the contemporary works, you can actually pretty quickly tell if you know some devices that are in operation in terms of the design process. You know, the acquisition of architects getting a hold of animation software. And projects are out there in the world now that are actually probably more representational of the software capacities rather than some change of philosophy in our world. And so it's not a philosophical or a cultural or social reference, but rather purely based on the machine's ability to reconfigure our world. And so very quickly you can look at a project and say, I know that they built this using Maya.
They designed it using Maya. They didn't build it using Maya.
So, right, sorry, designed it. Right.
It's different.
That's right.
And I'm sorry, the Sydney Opera House was designed on a napkin, but it took over Arab.
No, I understand that, but I'm saying in today, we're seeing a direct relationship between the representation of what becomes built, or the formal characteristics, are references and representations of the machine's ability to create.
Give me one specific example.
Ali Rahim. Look him up. Ali Rahim. ALIRAHIM. And go to this tower. Yeah, this tower. The formal conditions that this, you might find some better images of it, but clearly it's made by, designed using Maya because of Maya's ability for the physics of the construction. You cannot build this thing in the digital world using an architecture software. It has to be the animation. Yeah, that. So I still kind of play my question out here.
Yeah.
Is this built or is this a virtual model?
This is virtual model.
Well, see, I think that happened before too. I think you could recognize, let's say, Frank Lloyd Wright's Mile High Skyscraper just because the way he did the rendering. Now, maybe it was tied to him, the way his style with the color pencil is, and somebody went with black and white and different ones. If it's in the realm of projects, I think we had that all the time. I do not think that's a novelty. So you have a certain technique, it goes with ink versus color pencils, and I think I was part of that world when we did the renderings black and white in a certain chiaroscuro, emulating actually Piranesi.
I mean, it's actually the same as Professor Niemann's example of the typewriter and the effect of the typewriter, the difference in typewriters that are producing differences in paper.
Yeah,
things that are turned
it has to do with the palimpsest type of idea when you draw or when you drew, because something is left over, it becomes a personality. All your handwritings you're still different. If you type in Word program and you take the default font, everything is in Calibri and we can't distinguish who wrote it. So yes, having and manipulating that software, I think that's actually a trademark, and I think that's a good thing. Because that happened throughout, as far as I know, in architectural history. Look up Sant'Antonio Sant'Elia. He never built anything. He got shot in World War I. I'm serious, but his Antonio Sant'Elia,
S-A-N-T.
Elia. Antonio. No. I'm sorry.
S-A-N-T.
No, without the S at the front. Antonio Sant'Elia. There you go. Now he didn't even reach the age of 30, but distinguished style. I bought the book just because of the rendering, because it just, wow, I mean, I get goosebumps right now talking about it. And everybody knew about it, so his career is very, very short for an architect. In that particular style, and also nothing got built, by the way. Very brief time, but what that basically means is that was recognized, and it was like this instant thing, because that's what you a little bit have here in a digital realm. And I think to me that comes then again out of imagination. You're interesting, you were mentioning actually, what's it called? What did it, the software again? Maya. I worked with a student over 10 years ago. He used Maya. We had Maya at the time, and basically recommended, he wasn't really into architecture too much, but he then basically went into film and is now working on his second full-length feature. What I'm trying to point out here is that the idea of representation, which I can consider architecture, is a difference from when you actually build a building. It can be the whole step all the way, but let's say all the Pixar movies, when you look from the very first shorts to the ones now, they create their own reality. Everything, their own distinguished style, how they render, how they abstract, and I think that has all to do with imagination and certain styles, and I think we're glad we're recognizing that. So, but I am pretty concerned, I think it's not built yet, but I think it's going to look very different when it is built. Because here is where I think the biggest struggle is for us, because in academia we talk a lot about how those buildings actually will be made, but actually very few still are made right now. If you make a living, you do go back what I consider traditional tectonic, and then I consider digital tectonic. And yes, we have robots who now are bricklaying, but you think about the brick, basically the Romans had bricks. It's still the same method. You use mortar on top of each other and you make a wall. I mean, in a way, we are really, really lagging in general when it comes to the actual construction. But going back to that style thing, so you're recognizing because you're intimately involved what software it uses, I actually think that's a good thing, because that's a rendering technique, you're looking at it, what you may be liking it, but you're using it in order to get across an idea. right? I mean, to me, still, I'm looking at the architecture. Yeah, it's rendered well, but that's what excites me.
Well, if you think about the ING building in Amsterdam, for example, it's really high tech. And for the Dutch, doing this doesn't seem to me very difficult because they have all the product designers in construction, you know, and they oversee the construction sites very well. It's way different from, yeah, there was the building. If you look at that building, I mean, it took 3 years to just correct all the mistakes that were in there, but that is feasible in Amsterdam. I don't think that you will find and go out and find this, but again, ING headquarters, so, you know, they have a lot of money to put in there, but I talked with these firm that was delivering the building, and it took them 3 years to adjust all the mistakes and connect them. But this was followed up, and you know, I have a book on it. I mean, just the drawings and the details, and you know, to make this building work. Now, if you go to De Luca and you want to remodel something there, you're not going to locally find the craftsmanship able to do this in Lubbock, Texas, where, you know, that is where whenever you design something, it is contingent upon the context, which is, you know, what is the available knowledge in construction in order to perform something. So it's not just the machines, it's also, I think, the clever know-how. And I know, you know, we worked in, you know, a construction site in the Netherlands is like clockwork orange. I mean, everything is ordered and everything is precise, and all the documents and all the details are there and all the specialists are there. And so that is where the build, you know, that's an art by itself. How do you actually make a building like that? You know, how do you do it when you come back to Lubbock or West Texas and say, how can I make a low-cost version of that? And, you know, that is another challenge. You know, I think a great architect has to be able to design as much for high technology as well as low tech. And, you know, Australians are very good in kind of trying to find low tech, also for budget. You know, a great architect can design for low budget as well as a big budget. And, you know, it's not the design build in this context, if you design and teach in the Netherlands, is quite different because you do have all that expertise available to you. So you can, you know, the machine is one thing, but you still need the manufacturers, the constructors, the builders. You know, it goes hand in hand. I don't think you can do anything by yourself as architect. I believe in teamwork. You know, to make a good building, if you want to make a real good building, it's not just your ideas, it's not just your computer, it's not just, it has to come from many, many, many facets. And I think we have forgotten that a little bit. And I think that's dangerous in an architectural institution, that to get that message across, your building is going to be but as good as the people who make it too. And, you know, that should be a dialogue because you can learn a lot of constructors, I think.
We are coming close to the end of the time for the dialogue. Just to give a closing, if you guys want to say anything in particular before we go ahead and end the dialogue very quickly.
I don't know. I'm going to... I want to end. I don't know how to end this, but I know how this ends.
Is that the Bible or something?
No, it's not, but you will get it. I'm from Belgium. So Le Corbusier used this pipe as enigma of closing this book, An Architecture and Revolution, as a machine. To him, that was a machine. It's the only time you get an instrument like that. And this became for Marguerite, like, you know, this is not a pipe. Marguerite grew up, well, I grew up 2 blocks away from where Marguerite was painting, René the Surrealist, this is not a pipe. And, you know, there always are, what Le Corbusier was intrigued by this design, he used this pipe, but he was intrigued and tried to find the people that actually teamwork that designed this pipe and made it. And he never really got...
Look at the painting over there. The painting has the pipe. He always has the pipes in the painting. Yeah, it's in there.
So why I want to end is like, we cannot tell you what technology is going to be in 20 years. It's going to move all. Be curious. You know, just try to figure out how did they come up with this. But, you know, as architect, I think, you know, architects use different sources of inspiration. The machine might be just one as a metaphor to suggest possibilities in design, but also to be a lifelong learner and never lose your curiosity and discovery, you know, and try to figure out how, you know, we can learn from the iPhone quite a bit and how to better our methods of building our buildings, because look, how much is this worth, right, in which we're sitting. So I like the pipe because, you know, they're just from my country rather than a hammer. I don't smoke the pipe. I don't smoke the pipe, but that's a bigger joke even. Anyway.
I want to go back to Moholy again. I've been convinced for a long time that just from reading stories about Moholy that if he had computers, if he had digital technology, he would embrace it fully, because that was what he was about. He was about looking at current technologies and how you could bend the current technologies and approach it in a non-standard, creative way. You know, one story that comes to mind is he was very fascinated in new materials of the time. Plexiglass, what became plexiglass, acrylic sheet. He started to use transparencies and acrylic sheet to make transparent paintings. So, for instance, he would paint on one side of the plexiglass or the acrylic, and then layer it, and then paint on another layer and layer that. And so he started to create these almost quasi three-dimensional paintings, because the surface now was made up of a series of thick layers. He also did things with very thin plastic. So he was experimenting with quote, new technologies, new materials, and seeing what he could do with it. He didn't have a lot of money, so he obtained the plexiglass through donations or scraps or things that were broken. And later on, he wanted, you know, because acrylic sheet was plastic and it could be heated and bent, he started to experiment with sculptures with acrylic sheet. And one of the most fascinating things about those experiments is that let me describe to you how he did some of these sculptures. He took a sheet of plexiglass and he wanted to somehow bend it. So what he did is he took an inscribing tool and he etched on the plexiglass a curvature of some sort. Now, once again, he didn't feel he had the skill to cut plexiglass. You know, again, this is Moholy getting consultants, collaborating. He knew this craftsman. Moholy was Hungarian. He knew this Hungarian craftsman. I can't remember what his specialty was, but he knew how to use a scroll saw or whatever. So he scribed those things. He got the craftsman to cut the shape. And so he took these shapes of plexiglass and in his house, in his apartment, he put them in the oven, he heated them up, and then he took them out and with gloves he bent them. The gloves of the time were not very like you have today. you know, they weren't heat resistant or anything like that. So he ended up having to do it with his bare hands. Yeah. And he had his kids there, and so what he would do is he would heat it up, and then he would, you know, with his bare hands, bend it, and he jumping around, and the little kids thought it was a game, and so they started jumping around and laughing, and then he'd come back and do it again. I mean, he was kind of crazy that way. But if you ever get a chance to see these sculptures, they're kind of small. They're beautiful. They're beautifully crafted. So maybe that goes back to the hand thing, but that's what he had at the time. If he would have had special gloves, he would have, you know, he was using whatever was at his means.
I think that's almost true for everybody who is imaginative. I think anyone would use probably all the technology to his or her advantage. Same goes for Le Corbusier in terms of materials. He was interested in concrete and materials. As far as what I have to say for you, question everything, including what we just said. Be curious, go out there, seek, and make your own findings.
We want to end this, and thank you so much, professors, for being part of the panel. We have one more dialogue happening in April. I believe it's the 12th of April, if I'm not mistaken. 18th? 19th of April. And it's on interdisciplinary. So thank you again for coming tonight, and we'll see you guys next time.